I'll show you a couple of problems using the divergence theorem. The first one, notice, is a hemisphere, the top half of a sphere, and so we're going to change this integral into a triple integral over some region using the divergence of f. So we need to compute the divergence of f. I like to use my TI-89 to do this, so I'll go type this into my TI-89. I did share the program with you that does the divergence on the TI-89, so give it a try. Comes out to be just a 2. I like those that come out to be just a 2. So we need to do the triple integral using the 2. And the region needs to be the upper half of sphere, radius 1. Now, the sphere of radius 1 would best be described in spherical coordinates. So if we're going to use spherical coordinates on this, we need a rho squared sine phi, and we'll need rho, since it has a radius of 1, to go from 0 to 1. We'll need phi, since it's the top half, to go from 0 to pi over 2. And then we'll need theta to go all the way around. So there's our integral, and that would best be handled with the TI calculator, but I don't have mine going right now, so I'll just go ahead and integrate that. So the integral first with respect to rho would be rho cubed over 3. From 0 to 1. So that'd be 2 times 1 over 3 would be 2/3 sine phi, and then minus 0. So that comes out to be a 2/3 sine phi. Now we need to integrate that from 0 to pi over 2 with respect to phi. The integral of sine phi would be the cosine of phi, negative. And we still have the 2/3. We'll go ahead and fix that up. From 0 to pi over 2. So plugging in the pi over 2, cosine of pi over 2 would be 0. Cosine of 0 would be 1. So we get negative of a negative 2/3, which would be just a positive 2/3. Finally, we need to integrate that from 0 to 2 pi with respect to theta. That would be a 2/3 theta, which would be 2 times 2 pi, which would be 4 pi over 3 minus 0, which would just be 4 pi over 3. Now, in the next one that we're going to do, our solid is a box, and this one the divergence, again I'll do on my calculator, comes out to be an 8x z cubed. So our integral is going to have an 8x z cubed, and we're integrating over the volume of this box. And this box is a cube. We can do any order. Dx, dy, dz would be fine. -1 to 1, -2 to 2, -3 to 3. And again, this is easy enough to do by hand. The integral of 8x with respect to x would be 8x squared over 2, or 4x squared. go from negative 1 to 1. So that would be 4 times 1 squared is 4. Negative 1 squared is also positive 1 times 4. And so the first integral comes out to be a 0. Well, when we integrate that with respect to y from negative 2 to 2, we get 0. When we integrate that with respect to z from negative 3 to 3, we get 0. Now, not everything works out this nice when you're doing integrals, so again, you can do them on your calculator if you need any help.